Greetings and good afternoon all, and welcome to our first ever virtual Kendall Connection Live. I am John Bain and I will be your Kendall host for this premier event. I would like to thank you for taking the time to join us virtually today, and I hope you and your families are all doing well and staying safe during these trying times. It has been quite a ride thus far, and we look forward to visiting you all in person soon. On today's agenda, we have Rob Rod, our network specialist, opening with a talk on hardening your OT network. Phil Reese, our services specialist, will follow this with a presentation on the importance of risk assessments and maintaining your system's safety integrity by using certified remanufactured components. We will then get into Rockwell's Safety I/O, and this will be led by Raina Carlson, our PLC and HMI specialist. Ross Skoma, our motion specialist, will then present on what's new with motion safety products, focusing in on the newly released 843 ES SIP safety encoder. And Adam Clements is going to make sure you all stay awake throughout the entire presentation by closing with the new MSR 55P safe speed monitoring device with back EMF capability and a demonstration on how to calculate GuardLink voltage drop. I encourage you all to ask questions throughout the event. Our presenters will not stop to answer the questions during their presentation, but we'll review them after the final presentation has completed. I think most of us have become very adept with virtual platforms as a result of the COVID-19 pandemic, but just to be on the safe side, for anyone new to Teams, let's take a moment to review the live event structure. To ask a question, please select the My Question tab, which should be located on the middle right side of your screen, as seen by arrow 1. To type your question, go to the lower right-hand corner on your screen, as shown by arrow 2. And finally, if you wish to conceal your identity, select the Post Anonymous checkbox, as shown by arrow 3. Doug Mason and Eric Paquette, who are producing this event, will publish your questions and comments as necessary to avoid any duplication or foul language. Again, after the final presenter completes their portion, we will review and answer the accumulated questions. Before we begin our event, I'm happy to inform you that Kendall Electric is now a proud distributor of SensoPart for your vision and ID sensor needs. SensoPart has a great product portfolio and commissioning tools to set up your solution, and as always, it is going to be backed and supported by our service excellence. And though we may be limited on visiting you in person and demoing this new product line, we do have the capability to meet over Microsoft Teams and several other virtual platforms to present it to you. Please contact your Kendall Electric account manager for more information. And since Kendall is not providing you with a tasty free lunch today, we are permitting you to have a pre-5 o'clock toddy during the event for those of you who are at home. With that being said, sit back, relax, and enjoy the show. Please take it away, Rob.
Thank you, John. This is Rob Rodriguez-Pellizzari. I'm here to talk to you about network hardening today. This is a view from a program called Shodan, and what it shows is it shows open ports on Ethernet IP addresses. So another way to describe that is these are open ports for our Ethernet IP that we use for Studio 5000 and RS links. We have each one of these red dots represents a piece of machinery or a node that is viewable outside of the internet firewall on each one of these locations. Now, when I explode in a little bit further, we can see a map of what those open ports look like for Michigan. And moving forward into what they look like in Grand Rapids and surrounding areas. Now, just because I have 3 dots currently, red dots in Grand Rapids, that does not mean that if I were to look at it real time today, I would have those same red dots. What I notice is that as machines come online and offline, those machines that have this exploit on them show up, in varying different ways. So today we're looking at 3 items in the Grand Rapids area that have open ports and are viewable from outside of their firewall, but it very well could be 5 tomorrow. The United States is the leader in open ports, and we get this distinction because we work very heavily in automating our manufacturing equipment, and we're the leader as far as deploying automated equipment. And so because of that, and because of the fast pace that we've had to deploy our equipment, we've learned that we have a lot of open ports, and these are items that we can all work on and try to fix. Some of the ways that we have different security threats are through security threat vectors. Some are man-made, some are worms and viruses. There's some sabotage in there, of course, and unauthorized access is pretty much a high event. Think about it this way: an internet IP address that has an open port is nothing more than a phone number. How many of us have dialed the wrong number before? Some other unauthorized actions are by employees. Some people may connect into switches that have open ports and get an internet connection. And other things are a denial of service. A denial of service is an attack that happens usually from outside of your network, but it can be propagated by a virus also that sends multiple requests to a workstation or a machine or a computer node and overwhelms it and causes that network port to shut off. Then, of course, theft, that's an obvious one, and application patches. That's a big deal too. We've all ran through it before where we've received an update from unknown operating system company, only to find out that they gave us a exploit and we had to re-update with a different patch very quickly. That happens. So while we're looking at this large wheel of security threat vectors, I want everybody to think about what we can do. Obviously, many of these threats happen and are hardened at the point where we see the internet, which is your firewall right there as you're leaving your building and your company. But there are other things that we can do to mitigate some of the smaller issues here, which are unauthorized employee actions, unintended employee actions, just a mistake. You know, we can avoid these things by physical networking hardening. Physical network hardening can be as simple as using the right patch cable. There are keyed patch cables. Military has been using them for years. And these keyed patch cables will only fit into a certain keyed port. This is designed to keep people from putting the wrong patch cable in the wrong patch panel at the wrong time. Many of these keyed patch cables are also color coded. So that is one form of network hardening. Another one is that we can put lockout and lock in devices into our zone enclosures, and we can lock the zone enclosures with a key lock or a card lock. These two features used in tandem together allows us to get that little bit of time that we need to dissuade somebody from continually trying to exploit our piece of machinery in a physical way. The picture on the far right is a picture of what a lock-in device looks like. That is a picture of a patch panel, and it looks a little different because it's got these blue and red pieces of plastic that protrude from the actual RJ45 port. And there's a little hole in the very bottom of that, and that is your keyhole. And when you turn it to the right, you lock in a patch cable or you lock out a patch cable. Moving along with that same sort of solution, we have on the very left-hand side, that is the lock-in device that I was talking about. And right next to it on the right is the lock-out device. That's a device that would be plugged into an RJ45 port, whether it be in a patch panel or whether it be in a switch, and it would keep somebody from putting in their own patch cable. And maybe they're there to do a legit job, and maybe they're just trying to be a social warrior on Facebook. Whatever it is, it allows you to be able to control port access at the switch level or at the patch panel level. Moving to the right, we have the USB lockout device. The USB ports are probably our most heavily exploited ports that are out there. Obviously, we can get auto run viruses, and they can be in our thumb drives. And as soon as we plug in a thumb drive into a machine, that machine unfortunately just received a virus. So not to say that all thumb drives are bad. I'm just saying that we can control who plugs in what device and where. That's the idea. And then moving to the far right, that is a lockout device for a LC connector on a fiber patch panel. We use this device in the same way that we would use the other lockout device, where we can control what fiber patch cables get plugged in where. That is it for physical network hardening. This is Rob Rodriguez-Pellizzari. I'm going to now turn it over to Phil, and Phil's going to talk to you about Kendall related services.
Thank you, Rob. Hello, everyone. My name is Phil, and I'm a services specialist with Kendall Electric. Kendall Electric has a number of safety solutions available to support your business needs. Hazardous energy control, often called lockout tagout. We have capabilities to support overall policy, individual machine procedures, employee training, and auditing. Additionally, our lockout tagout solutions can be digitally enabled to enhance program management and deliver a return on investment. Arc Flash electrical safety. We have capabilities to support short circuit studies, protective device studies, arc flash studies, and arc flash labeling. Additionally, our program maintenance solutions can help manage study documents to ensure relevancy. Cybersecurity. We have capabilities to proactively identify common vulnerabilities and exposures, unsupported operating systems, and suspect communication patterns within the OT network. Additionally, our assessment solutions provide a prioritized listing of concerns and actionable remediation recommendations. And lastly, machine safety services. We have scalable capabilities to support a wide range of machine safety objectives. Potential solutions can include machine safety conformity audits, risk assessments, functional specifications, and design verification. Additionally, after your machine safety system is in place and operational, we can provide validation services to ensure targeted machine safety performance is achieved. Normally, we would discuss one of these safety services in greater detail. However, these are anything but normal times. How has COVID-19 impacted you or your organization during the past several weeks? Many of us have experienced changes in the way we engage work. Many of us have experienced changes in the responsibilities of home. Given these unique circumstances, I want to focus our discussion on services that you can use today, right now, to make a positive impact within your organization. This got me thinking about remanufacturing, specifically how remanufacturing is uniquely positioned to support existing installed safety products and potentially provide spending relief. For many of us, spending of any kind, whether OpEx or CapEx, has tightened a bit, yet we still have organizations to support. This can be a challenge and opportunity when it comes to safety products. When these products fail, many may think that the only option available is a new product purchase. 62061 safety integrity level and 13849 performance level ratings used to implement overall safety systems depend on the integrity of interconnected safety products. The performance of these safety products depend on subassemblies, such as components, chips, boards, and of course, overall product assembly. This often leads to the perception that repair of safety products is not a viable option. It's not worth the risk, and you can certainly understand why. Product safety is not necessarily a simple process. Failure of safety products may result in danger to both people and the environment. Because of this, their subassemblies, design, and overall construction are based on industry prevailing standards, such as ISO standards, European standards, robotic standards. In some instances, these standards are broken down further. For example, Type A standards deal with overall functional safety, Type B standards focus on the generic aspects of safeguarding, and Type C standards are specific to types of machines. Additionally, these applicable standards will change based on product type. For example, many standards applicable to programmable automation controllers and variable frequency drives will be different. During product design and build, there will often be independent or third-party concept inspections, assembly inspections, and final certifications. These final certifications enable safety product performance level and safety integrity level ratings to be defined. Sending these products in for repair can absolutely create a problem. Thus, the belief that new product purchase is the only solution for replacement. Alter or change a safety product's components, chips, boards, or overall product assembly, and you knowingly change its performance. With a change in performance, the safety integrity level and performance level ratings then become unknown, and the capability of the overall safety system is compromised. However, there is an alternative, a cost savings alternative to new purchase replacement: remanufacturing. Rockwell Automation has the unique ability to remanufacture many of their safety products. This remanufacturing process follows ISO 9000 standards. This documented process ensures consistency while enabling safety product performance level and safety integrity level certifications to be maintained. The infograph shown here provides an overview of the Rockwell Automation documented remanufacturing process. Now, there's a lot of detail here, so let's focus on a few key points. Revision enhancements. The overall product is reviewed for any engineering updates or enhancements. Identified updates are implemented using original equipment manufacturer parts. For example, if there is a documented performance concern with a component, the component will be proactively identified and replaced with the enhancement. The use of OEM parts within the correct product build ensures safety certifications are maintained. Component verification. Any inoperable components will be replaced using OEM parts. These parts are installed in accordance with original manufacturer specifications. Additionally, operational components which are aged or identified as marginal are proactively replaced using OEM parts. Using OEM parts installed in accordance with manufacturer specifications ensures that safety certifications are maintained. And lastly, dynamic testing. Factory trained technicians certify full unit functionality. This like new functionality is validated using proprietary Rockwell Automation equipment. We don't just repair Rockwell Automation safety products. We remanufacture to new. As the recognized distributor for Rockwell Automation, Kendall Electric has the unique ability to maintain a product's original safety certifications. We do this and can typically deliver savings of up to 50% of new. Additionally, as needed, we have extended warranty and next day replacement solutions available. If your organization's spending is tightened a bit, remanufacturing may provide a solution for you to make an immediate and positive impact within your organization. One last note, as your organizations begin to ramp back up, the need for product training may arise. If you find the training is needed, please take note of our new e-learning solutions. 15 on-demand training modules are now available. This interactive platform provides training where and when most convenient for your organization. If you have not yet heard about Rockwell Automation e-learning, please engage your Kendall Electric account manager for additional details. Randy will be up next to discuss new safety IO offerings and solutions. Thank you for your time, folks, and have a safe day.
Okay, thanks, Phil. Hello, everyone. My name is Randy Carlson. I'm one of the Kendall Electric Automation Specialists covering the Western Michigan territory. And today I'd like to give you a brief update on some of the newer safety IO modules offered by Rockwell Automation. In particular, we're going to take a look at the Bulletin 5069 Compact 5000 IO, the Bulletin 1756 ControlLogix IO, and the Bulletin 5094 Flex 5000 IO structures. Let's start out with the Compact 5000 IO. For those of you that have been using either the ContactLogix 5380 or 5480 controllers, this IO structure might look familiar to you. This IO structure came out at the same time as these new processors were made available. So in the center picture on the bottom there, you see an example of the 5069 IO modules connected directly to, in this case, a ControlLogix 5380 processor. In this case, we would consider this local I/O because the I/O modules are attached directly to the processor. The picture on the left-hand side shows the same I/O modules, but in this case, they're now connected up to an Ethernet adapter. So through the Ethernet adapter, we have the ability to use this as distributed I/O. So these I/O structures can be out on the Ethernet IP network communicating back to the ControlLogix or ControlLogix controllers. Notice this I/O structure is compatible also with the 5580 or L8 ControlLogix processors as well. The picture on the right shows an example of the newer 8-channel safety input module and 8-channel safety output module. And the red color makes it easy to distinguish that these are safety rated modules. Taking a little bit closer look at these new safety modules, keep in mind again, these are compatible with the 5380 compact GuardLogix and the 5580 GuardLogix controllers. At this time, the Compact 5000 I/O structure is not compatible with any other PLCs. A couple of the features that kind of set this new I/O structure apart is a faster safety reaction time. For those of you that may have already used and deployed the point guard I/O modules, you might recall that the safety reaction time on the point guard input is rated at 16 milliseconds, and I believe the point guard output safety module is rated at 6 milliseconds. So here we have an improvement in the safety reaction time. So what does that mean for you? Well, potentially it could mean a smaller footprint for your machine on your plant floor. The idea here being we may not need to mount devices, safety devices like a safety light curtain or a safety mat as far away from a pinch point or a dangerous point, because if there is a demand placed on the safety system, we're able to react to it quicker. So again, it might reduce the overall footprint of your machine. Another feature that you'll see in this Compact 5000 is the ability to configure the safety output module. So in the case of the 8-channel safety output module, we have the ability to configure it for a sourcing wiring scheme or a bipolar wiring scheme. Now, when these modules are used in an overall safety system, we can achieve up to and including a SIL 3 Performance Level E safety rating. For those of you, again, that have used the point guard IOs, you might recall that for the outputs, there were 2 different output modules. One was a sourcing output module, the other was a bipolar output module. And in the case of the bipolar output module, it was only 2 channels. So on this module, again, we have the ability to set it up for sourcing and bipolar. The other note there at the bottom of this slide, it's important to note that it would require version 32 of the Studio 5000 software, and likewise version 32 of the firmware running on the PLC. For those of you, again, that may not have used Compact 5000 I/O, there's a couple nice features that make this I/O a little bit easier to work with. Notice in the left-hand picture there is removable terminal blocks with this I/O structure, but also notice that the I/O status indicators are mounted directly next to the wire termination points of the removable terminal block. So most other I/O structures have the LEDs giving us status populated up at the top of the module, so it's not quite as easy to correlate which points, I/O points, are on or off. Now we have those indicators right alongside the termination points. On the right-hand side, you see an example of where now we are printing on the face of the module type and the catalog number. So it's much easier to determine what modules you have in your chassis with them printed on the face of the module, rather than the older method of printing them on the side label, which you didn't see when the modules were in the chassis. So again, make note of the fact that these removable terminal blocks are sold separately. So this is similar to ControlLogix, where you purchase the part number of the module, and then you also need to purchase the appropriate terminal block for that module. Taking a closer look at some of the possible wiring scenarios, first on the 8-channel safety input module, and starting from the top, you'll see channels 0, 1, and 2 are set up for single channel wiring. So there are single channel safety devices that are wired into each one of those channels. And notice also on channel 1 and channel 2, we're making use of the test output feature of the module. So in this case, through channel 1 and channel 2 with the test output, we are able to test that channel for a 24-volt short to ground, for instance. On the right-hand side there, you see the channels are set up in connection pairs. So channel 0 and channel 1 are a pair, channel 2 and channel 3 are a pair, and so on and so forth. So when you look down at channel 6 and 7 as a pair, those are set up with a dual channel wiring. So in this case, we have a dual channel safety device that is wired into channel 6 and channel 7. And again, we're making use of that test output feature. In this case, we have the ability to test 24-volt short to ground and also cross-channel fault detection. On the output module, again, some examples of possible wiring starting at the top. The P terminal of channel 0 we've set up for a sourcing output, and this is single channel sourcing to a contactor K1. In this arrangement, we would not be making use of the N terminal on channel 0. If we move down to channel 2, there's an example of a bipolar output. So in this case, the P terminal is switching the 24-volt side of the K1 contactor, and the N terminal is switching the common side of that contactor. Then moving further down the module to output channels 4 and 5, here's an example of dual channel sourcing wiring. So channel 4 and channel 5 are sourcing out to the K1 and K2 contactors. And then notice at the bottom there, channel 6 and channel 7 are two examples of, again, bipolar, where the P terminal switches the 24-volt side and the N terminal switches the common side. Something else to note there at the bottom of the terminal strip is local actuator plus and local actuator minus. This module is an example of one of the modules where we need to provide 24 volts to that LA plus and LA minus terminals for proper use of the module. This module does not make use of the SA or sensor actuator bus that is created when the modules are joined together. Okay, switching gears to the Flex 5000 I/O structure. For those of you that have been around for a little while, this might look familiar to you. Back in the mid to late 90s, Rockwell introduced a very popular I/O structure called 1794 Flex I/O. And this Flex 5000 is a refresh or re-roll of that I/O structure. Similar to what I mentioned on the Compact 5000 I/O, this Flex 5000 is compatible today with the ControlLogix L8 or 5580 PLCs and the CompactLogix 5380 and 5480 PLCs. It is not compatible with any of the other PLCs at this time. Also, similarly, in terms of software and firmware, if we're going to be configuring the standard I/O modules of Flex 5000, we need to be at version 31 of software and firmware. If we're going to be deploying and configuring the safety I/O modules in this platform, we need to be at version 32. And it's also important to note there, similar to the point I/O structure, we have the ability in this I/O structure to mix and match both standard and safety modules in the same chassis. Taking another look at the modules here, starting from the left, the adapter in this case is a dual channel wired Ethernet adapter. This is the adapter that puts the modules out on the Ethernet IP network. There is an option if your architecture demands using fiber optics. You can also choose a fiber optic adapter for this I/O structure. Then moving to the right, you'll see an example of a 16-channel safety input module and a 16-channel safety output module. And then in this I/O structure, we now have a 4-channel safety rated relay output module. And that's the last module on the right there. Back on the left-hand side, notice these modules, when properly deployed in a safety system, we can achieve up to a SIL3 performance level E system. The last IO structure that I wanted to update you on is the ControlLogix IO structure. For those of you that have been around again for a while, you know ControlLogix was introduced in the late 90s. So there have been standard rated IO modules for the 1756 chassis for many, many years. And near the end of last summer, safety modules were introduced into this IO platform. So similar again to the other newer IO structures, we have enhanced safety reaction times for these modules. This 1756 structure also will support up to SIL3 performance level E. In terms of the channels, the IV16S is a 16-channel safety input module, and the OBV8S is an 8-channel safety output module. Notice the OBV8S is designated identically to the 5069 OBV8S. So this module shares the same features in that we have the ability to configure this module for sourcing outputs or bipolar outputs. And also notice the red color of the module to make it easy to distinguish that these are safety rated modules. This slide gives you an idea of how these safety modules can be deployed. So in the top picture there, we see an example of the modules in the 1756 chassis right alongside the L8 series processors. So these can be local I/O to a GuardLogix controller right in the same chassis, or they could be distributed I/O. So the second picture down shows the same safety modules in a chassis with an Ethernet adapter. So now these modules can be distributed out over an Ethernet IP network, either back to a ControlLogix GuardLogix processor in terms of a 5580, or down the bottom picture there, you see an example of a compact GuardLogix 5380 processor. Again, very similarly, we need to be at version 32 for our Studio 5000 software and firmware running in the controllers in order to support and configure these I/O modules. Okay, this is my last slide, and this is meant to give you a relative idea of the sizes of these different I/O structures. So you see an example here for the Compact 5000, the Point Guard, the ControlLogix, and the Flex 5000 I/O structures. And the idea here is each one of these configurations is configured to support 48 safety inputs and 24 safety outputs to give you a rough idea of the different sizes. And the third bullet there is also to make mention of the fact for the ControlLogix chassis, there is an optional cable that would allow you to detach the ControlLogix power supply and cable that power supply and connect it up remotely in case you have a situation where you just don't quite have enough horizontal real estate on your back panel. Maybe if you have room above or below the chassis, you can remotely mount that power supply and gain a little space there. In these examples, any hardware that's necessary to support that configuration in terms of the adapters or power supplies are also shown. I guess the last point I would make, down on the Flex 5000, remember that both the input and output modules, safety modules, are 16 channels. So in this case, we have 5 modules there. The first 3 are 16-point input modules to give us the 48 inputs. And then the last 2 are actually 16-point outputs. So we actually have 32 safety rated outputs on the Flex 5000 configuration that you see there. And with that, that concludes my portion. I'm now going to turn it over to Ross, and he's going to give you an update on some of the motion products. Thank you.
Thank you, Randy. My name is Ross Goma. I'm one of the drives and motion specialists up in Grand Rapids area. Today I want to talk to you about Rockwell's new SIP safety encoder and what it means for advanced safety functionality through across the drives that we sell and how we can integrate it. So To really understand what we're talking about, we kind of have to start with what is safety on a drive system. Typically, we look at it if we hit a safety input or a e-stop button, what do we want to do? And historically, we use contactors to disconnect the motor from the drive so that we didn't have the capability of the motor spinning while we're in the machine working on it during an e-stop. So that advanced into safe torque off inputs on the drive, which cut the ability of the transistors to fire on the output of the drive, which helped maintain the drives a little better over the contactors so that they didn't burn up while we disconnect the power under full load, and also allow the drives to come to a safe torque off or a safe to actually disable the drive at the same time. So from there, with the advancement of the safety over Ethernet, we now have safe torque off over Ethernet on drives like the 527, which gives us a higher safety rating than what we would get out of some of our other hardwired, but also makes it a lot easier to integrate and use. With the advancement of the safety processors, we now have the capability of some advanced safety functionality. We introduced this a while back with the 5700 Kinetix drive, where with the ERS4 module, we could add a VPL motor with a safety encoder and do monitoring of the axes and keep power to the motor while monitoring the functionality of that motor and keeping it within a certain range that we deem safe. So either a safe speed, safe position, or a holding. We could hold the position of the drive and the application without moving. We could add a secondary encoder to the drive and get a PLE SIL3 rating and get our advanced safety that way. But now we introduced the SIL3 PLE safety encoder. So it's a SIP safety Ethernet encoder that allows us to monitor the mechanicals of the machine and use any drive in a SIL2 or SIL3 style advanced safety function. What is advanced safety? We, in this case, slow down a conveyor. We can slow down the motor and keep it below a certain speed. We monitor for that speed and make sure that it doesn't exceed. If it does, we do another function to do a safe torque off or stop the machine. It gives us an advantage in that we can use the standard maintenance routines and with our safety analysis and allow us to maintain that machine while the machine is still running and continue to create product, or keep tension and not have to completely stop the machine, which increases productivity. We can also do safe direction monitoring where maybe there's a pinch roller, we need to clean something. In a standard case, we would have to move the rollers forward, enter, clean, move out, move them forward a little bit more, move in, clean. In this case, we can actually control the direction that the rollers are moving. And with the safety analysis saying that it's okay, we can clean them while they're moving and not have to start and stop, which decreases the amount of time for maintenance and cleaning. We can also do safe position monitoring, so we can monitor where an axis is at all times. And if we want to keep it in a certain window, we can keep it in that window and make sure that it doesn't interfere if we're working in another area of the machine. So with the 843 ES, it's a SIP safety encoder. It's dual Ethernet, dual channel safety. So it's got two control chips in it, monitoring the safety functionality to allow it to be a PLE rated device. We can, with the dual Ethernet, we can daisy chain them, or we can run them in a DLR loop. We can run them single. However we want to configure them like we would any other dual Ethernet device. The add-on profile and control flash upgradability, allow us to do quick, easy upgrades and integration with the PLC like we'd expect from the Rockwell devices. We can get up to 1 millisecond communications, RPI, to our standard PLC, so we can get speed and position monitoring from the encoder back to our standard PLC control to program in for conveyor movement or anything like that, while also getting a 6 millisecond RPI back to our safety PLC. So we can talk to both sides of the PLC, and we don't need a secondary encoder for one or the other. And it is full SIP safety compliant TUV certified. With the GuardLogix 5580 and a safety processor, we can get up to SIL3 dual channel monitoring. With a 5580 without the safety partner, we get up to a SIL2 PLD rating, and we can provide position and velocity values to both the safety and the standard machine functionality. It meets ISO and IEC standards for safety. A list of them up above on the top here of all the different safety functionality it hits. We can do star, linear, device level ring, resolutions of up to 15-bit for our safety functionality and 18-bit for our standard operations, and available in many configurations from solid shaft, hollow shaft, just like most encoders we'd expect today. So some of the advanced safety functionality that we're talking about are safe stops, safe operating stops, safe limited speeds. So what are these limited positions? We'll kind of go through some of the functions we can add to any drive now. First one is the safe torque off. This is standard safe torque off. We just disconnect power from the motor in the drive, and the drive comes to a stop. We can add to that with the safety encoder, safe brake control. So when it comes to a stop, we can engage a secondary safety brake and monitor that brake using our IO, safety IO, so that we have, if we have a vertical load, we can have a secondary brake monitoring and controlling. A safe stop one, we bring the drive to a stop. So we continue to run the drive, but we decelerate down to 0. And after it gets down to a complete stop, we can turn the safe torque off on at that point. So we can decelerate a lot faster and stop the machine faster. We can do this either as a time stop, which doesn't need any of the encoder functions, or with the encoder, we can do it as a monitored stop, which allows us to stop it as quickly as possible, but also monitor. So as soon as it stops, we open the door, so we may save time on our safety recovery by stopping and in a shorter period of time and monitoring that. Then we safe stop 2, we bring the drive to a stop, and then we maintain power on the motor so that we keep it at a 0 speed within a range. So this speed is monitored constantly, and if it gets outside of a certain speed, we can do a safe torque off at that point. But by maintaining power to the motor, we don't have to engage the brakes. We can hold the load, and we can hold tension and allow the machine to get up and running faster after we come out of our safe operation. So in many cases, this can increase production by minimizing the downtime during a safe torque off or a safe stop safety situation. We can also bring the system in a safe operated stop to a stop and monitor position so that we know that our position or speed are monitored within a specific value, and we aren't going to get outside of a range. So if, for instance, we may be stopped and have 0 speed or very, very low creep, but if we get outside of a specific position that we set, we are going to do a safe torque off and engage the brake so that the operator doesn't get hurt while they're working on the maintenance of the machine. Lastly, the safe limited speed. We can limit the speed below a threshold so that we know that it won't get above and possibly injure. So we can keep it at a safe rate that the operator can get out of the way if it would get too close. So with that, if it does get outside, we have within the safety PLC other functions. It calls another function, whether it be a safe torque off or another function to stop the machine. Safe direction, same type of thing. We can keep it within one direction and not another, so that if it changes direction for any reason, we can immediately stop the machine. Lastly, safe limited position allows us to keep our position within a window and make sure that we don't get outside of that. This would require a homing routine at the beginning of every startup for the safety PLC to physically find its home position and maintain its position values. We can't use an absolute encoder because of functionality of the safety. Safety analysis would require us to home every time. So what does this do? Safety encoder is through the Ethernet. So with a safety PLC and a safety encoder, we can take any Ethernet-based safety drive. So if we have a 527 or a Kinetix 5500 now with safety over Ethernet, we can integrate our advanced safety functionality into that drive and monitor and maintain that. Before we had to do it with a 5700, which with single axis applications or small applications became cost prohibitive. This brings us back into a effective range. We can also take, and with safety outputs from our PLC, integrate it into any drive with safe torque off. The safety rating of the application will be determined by the safety rating of the drive. So either SIL 2 or SIL 3, depending on the drive. Even though the encoder is SIL 3, the drive is going to dictate which safety rating we have. Here's some helpful resources, some different manuals that are out there for the new 843 ES. If you write these down, you can do a search on Rockwell's site or even on Google and pull these up. And there's some pretty good product profile, user manuals, installation. Also, the data sheet for any information you may need on that. Lastly, I want to take a quick peek at the safe brake control. We do safe torque off, safe stop one type applications quite often, but in a vertical load where we maybe have a brake on the servo or the AC motor, when we bring that to a stop and engage the brake itself is only capable of a PLC rating because it's a single point of failure. Brake is a single point and it only has inputs, no monitoring. So we don't get a very good rating on the safety side of that if we have a vertical load that's holding or some sort of static energy that could be introduced if it were to let go. So the safe brake control within the safety PLC allows us to add an external brake to the application and engage that brake when we come to a complete stop. Hold the access granted until the brake is engaged. We get monitoring back from the brake that tells us that it's fully engaged so that we know that both the servo motor brake and the safety brake are both engaged. And we have some delay control on when that brake is engaged while we're stopping so that we don't engage it too early and wear the brake unnecessarily. Kendall has now taken on the next in line for safety brake or for brake, servo brake applications. They have a pneumatic brake that has a milled input, milled output that allows us to put it between the servo and the application. Simply connect it between, and we have monitoring outputs that we can add to it to monitor that brake to make sure it's engaged. Pneumatic brakes are faster. They engage faster than electrical type brakes and hold up better over a longer period of time with zero backlash. So we've got a lot of advantages to the Nexen brake in applications that we just simply need to add a secondary brake for control of that vertical load or that static energy without re-engineering any of the mechanicals really into the application. So something to keep in mind for the future if you're running into those type of applications. For that, I'd like to hand it over to Adam, and he can talk about some of the components.
Thank you, Ross. Hi, my name is Adam Clemens. I am the component specialist for West Michigan. Today I'll talk to you about the new MSR55P safety relay and the GuardLink passive power TAM. The MSR55P back EMF monitor provides a non-evasive safe standstill detection on single and three-phase motors. They are designed to monitor the back EMF of all electric motors that generate resonance voltage while coasting to a stop, regardless of the direction of rotation. Most importantly, this is accomplished without the need for proximity sensors or an encoder. Offered in 24-volt DC, 115 and 230-volt versions, we can provide PLE and SIL3 ratings per the installation. The 55P provides broken wire protection and will immediately go into a safe state. We understand every application is different. On the front of the device, adjustable voltage and standstill time delay will allow you to tune the device to your application. Here is a typical application where we have contactors to start a motor, but no way to determine if the motor has stopped and it is safe to enter the area in a shutdown situation. I want you to focus on the connections from the motor to the MSR55P, 3 wires. Installation is simple. It can be easily retrofitted for existing applications. You also see utilizing the MSR55P's auxiliary contacts we can tie into existing safety strings. When ordering, make note of what type of motor you have. You will see in our chart that a VFD and servo application will require a larger standstill monitoring voltage. The GuardLink power tab is a great addition to the family of the GuardLink technology. It allows us to increase the voltage to the line to overcome potential voltage drops when maxing out the 32 device limit and or the 1,000-meter install length max. The form factor is the same as our other smart tabs. Showcases a bright indicator for status of power being supplied to the link through the tab. You are also able to connect GuardLink-enabled devices to the input port on the power tab. But the biggest question is, when do we need to use a power tab? Allen Bradley has made this easy with their GuardLink voltage drop calculator. This allows you to build your GuardLink system and calculate whether the system will need an additional power from the GuardLink passive power tab. It is recommended when voltage falls below 20.5, you add a power tab. Please take a look at the sample calculations on the screen. You will see tap number, device distance between taps, and what safety device is found at each tap. From these selections, the calculator will automatically total voltage consumption and will tell you where the power tap is needed. This is highlighted in red in the large blue arrow. The GuardLink voltage calculator can be found in Knowledge Base or Proposal Works. Please contact your local automation engineer or account manager if you have any questions or have trouble finding this. Before we conclude our KCL, John has some final announcements and will host our question and answer session. Thank you very much.
Hey, thank you, Adam. All right, ladies and gentlemen, that concludes our presentation portion of the event. We will now move on to the Q&A. There's still time to submit a question if you have one. We've received some feedback there that some people have had some difficulty posting questions. So if you have experienced that, please email your questions directly to feedback@kendallelectric.com or to your Kendall Electric account manager. So let's go with the first question. Rob looks like he answered the first few. How do you find and display the open ports map that Rob showed? He provided the link there. Can I get the PowerPoint on the network safety? Yes, we'll be sending out the entire PowerPoint after the event concludes. Also, can Rob Rod label the physical lockout devices shown on his last slide? Rob Rod, can you answer that, please?
Yeah, I sure will. What I'll do is I'll get the part numbers listed on that, and then before you submit that out, the whole presentation out to everyone, maybe we can update that slide with the actual part numbers on it.
Fantastic. Thank you very much.
Sure.
Where can I find information about the e-learning courses? Phil, can you please provide an answer for that question?
Yeah, absolutely. So e-learning course information is available online, and I think I can post this link right here. I get out to everybody so you can see it. So you can just click on that. That'll bring up all of the course details that you can take a look at. We did add a couple of recent courses, a CCP 152, which is a Logix function block. We did a CCP 154 with a logic structured text, and CCN 144, so CIP motion. So new courses are coming out all the time on that e-learning platform.
Great, thanks, Phil. What SIL is the ControlLogix safe modules on the Ethernet adapter? That is a question for Randy.
So the SIL rating for the ControlLogix I/O modules is not tied to or limited by whether or not they're used as local I/O or as distributed remote I/O. So those modules, when properly deployed in the system, can achieve a SIL 3 performance level E rating as both local I/O and distributed I/O.
Thank you. Next question, what is the current rating for the FlexIO safety output modules? That's another question for Randy.
On that, we actually have two output modules. So there is the standard OB16 safety output module that has a rating of a 0.5 amp per channel on that module. And then the safety rated relay output module has a rating of 2 amps per channel for a total of 8 amps over the module. You can go 4 amps on a channel if you decide to use just 2 channels of the 4. So 2 amps per channel or 4 amps if you only use 2 channels.
When will the SIL 3 PLE compact GuardLogix 5380 be made available?
And that's another one for me. That is a wonderful question because we have all been waiting for quite some time for the SIL 3 rated 5380s to come out, and they are now available. In fact, they are listed in Rockwell's SAP system and available for order entry and shipping. So they have just become available within the last week or two.
One more for you, Randy. You mentioned RSLogix version 3132 software requirements with the FlexIO. If you encounter a retrofit application, are there any firmware versions in the FlexIO head module that one needs to be made aware of?
Okay, so first I want to clarify the retrofit application statement there. Keep in mind that the Flex 5000 IO structure is not compatible at all with the older 1794 Flex IO. Having said that, I took a look at the Rockwell Product Compatibility and Download Center and put in the new safety modules for Flex 5000. And according to the Compatibility Center, there is no need to update the adapter firmware for the Ethernet adapter of Flex 5000. It shows compatibility with all 4 of the current versions of firmware for the Ethernet adapter in Flex 5000. I think that answers your question, but if I'm not correct, please let us know and we will further clarify.
Thank you. Ross, here's a question for you. With a PowerFlex 525 and 1 safety contactor, do you still get a SIL 3?
We'd have to go through the math, but with the 525 is only SIL 2 rated. So with 1 safety contactor, you'd still have to look at the overall SIL rating based on the likelihood of failure, which would be on that contactor. So I would believe you'd need 2 contactors, and we'd have to calculate it based on the contactor itself.
Okay. Would all of the PowerPoint files be made available? Yes, I believe so. Is this KCL being recorded? If so, can it be made available upon request. Yes, it is being recorded, and Kendall Electric has a newly released YouTube channel, and the event will be posted on the channel after it concludes. So look forward to it there. I just search for Kendall Electric in the search bar on YouTube. Next question. So the MSR55P does work on the output of a VFD. Adam, can you please respond?
The answer is yes. On page 29 of the user manual, it does a great job of showing a sample wiring installation for this. The key note would be you must use a shielded cable running back to the MSR55P.
Could you elaborate on what non-evasive means? I'm not sure at what point in the presentation this question was posted. Is this
the non-invasive part of this would meaning is to get safe standstill prior, you would have to install 2 safety proxies to monitor the shaft to know if it's spinning, or use a safety encoder. So non-invasive means that you already have 3 wires going to this motor. You can tack on 3 more wires, run them in a different conduit of some sort, which is flexible, and run it back to your device, meaning you don't have to make major changes to your machine to be used.
Thank you. Is the power tap only for transferring power for each safety device, or does it also transfer data connection? Another question for Adam.
The power tap transfers all of the data and the safety information. It is solely based to input more voltage to the system. Depending on which one you select, you also have the ability to have a tap, an actual tap, so you can go to a safety device on it. It acts as a complete pass-through.
Thank you, Adam. Phil provided the links for the e-learning courses. Thank you, Phil. That wraps up all of our questions. Give you guys a few more seconds to enter them if you have one.
Well, we're waiting to see if there are any additional questions. I would like to add in a little more information on the new SIL 3 5380s. For those of you that have used the 5380 SIL 2 controllers, you know that you can purchase safety with or without motion. With the new SIL 3 5380 controllers, you purchase safety and you get motion with that. So there are 8 catalog numbers. They provide SIL 3 with motion. So that is different than the SIL 2 5380s, where you could decide you wanted just safety without the motion. Just wanted to add that piece of information in.
Okay, thank you, Randy. All right, if we have no more additional questions, that wraps up our first virtual KCL. If you guys have any positive or negative feedback, or constructive feedback, I should say, on this virtual format, please send that to feedback@kendallelectric.com. We always are looking forward to, critiquing our presentations to meet your needs. So, as I stated earlier, a video of the presentation will be made available on the Kendall Electric YouTube channel, and we will provide the PowerPoint to you in some format, maybe Microsoft SharePoint or some other method. Thank you for taking the time to join us today, and have a fantastic afternoon. We look forward to seeing you or hearing from you soon. Take care, everybody. Thank you.